So this week we're going to continue, at least for the first half of the week, looking at sections 8.1 and 8.2, looking at the solving triangles. The idea is we got to figure out the measures of all the angles and the sides. And there's 5 cases we're going to look at. 3 of the cases use what's called the law of sines. The other 3 cases use the law of cosines. So first, just a review of which cases fall under the law of sines. So when we describe these cases, we're describing what information is being given to you and the placement of So here's the 3 cases. So for law of sines, anytime you start with 2 angles, that's always a law of sines problem. Whether it's angle, angle, side, you know what? I'll draw a picture of each one of these. Or angle, side, angle. Both of those are problems we would solve with law of sines. Here's how an angle, angle, side problem would look. So they're going to give me 2 angles, and they're going to give me a side, but the side that they're giving me is not the one that's between the 2 angles. So let's say this was 110, this was 30, and now I need a side that's not between them. 15. That's an angle, angle, side problem. When I say the side is between them, that's going to be the second case. That one would look like this. Let's say this is 115, this is 12, and this is 45. In that case, you're still being given 2 angles and a side, but the difference is the side is the one that's between the 2 angles, or another way to say it is it connects the 2 angles, versus the side that doesn't connect 2 angles. Okay, we talked about both of those cases they were on the test last time. Okay, the third case, this is the one we're going to spend the rest of the time on today. We started it, but we didn't do the other couple things that can happen. That is side-side angle. So the big difference with this one is you're starting with 2 sides instead of 2 angles. So let's say you had something like 8, 11. And it's important that the angle that I give you is not between the 2 sides. If it was between the 2 sides, we're going to have to look at that spot. Okay, that's not something we can do today. So I have to give you either this angle or that angle. Either one. Let's do this one. All right. What did I say this angle was? The top 20? 20. Okay. So here's the 3 things that can happen here. You end up with 1 solution for everything you're trying to find, 2 solutions, or it ends up being no solution. We talked about the 1 solution case on the test. That's the case we've already gone over. So what we're going to look at is what happens when there's 2, and then what happens when there's none. Okay, those are the 2. All right. So as far as really formulas, it's the same formula as last time. So we don't need anything new there. And it's sine of alpha over A equals sine of beta over B equals sine gamma over C. So there's 3 parts to this law. Does anyone remember how many parts at a time you use? Yeah?
2.
2. Either the first 2, the last 2, or the first one and the last one. And you're always going to set up something that looks like this. And does anyone remember what we called that when you have a fraction on each side of an equal sign? So pretend like it wasn't, sines and cosines, but like an algebra 1 problem. Something like that. What do you call that type of equation? Ends with a P? Yeah, that's a proportion. And whenever you solve a proportion, there's a technique you use. Does anybody remember the name of how you solve a proportion? Yeah? You always cross multiply. So for law of sines, every problem we do today, it's going to involve cross multiplying. All right, so what we're going to do first is we're going to take that information, we're going to draw it, see what kind of triangle it is, and then if it falls under one of the 3 types that I just mentioned here, then we'll go ahead and try to solve it. All right, let's make triangle again. This is not to scale at all. So let's put A at the bottom. And wherever you put A, remember alpha goes across from it. Let's make this side B. And then wherever you put beta, it has to go across from it. And the third side we haven't labeled has to be C. And the angle across from that has to be gamma. Okay, so using the 3 letters that I showed you guys earlier, what type of triangle is this one? Yeah?
The side angle.
It is the side angle because you know 2 sides, and the angle that you know is not the one between the 2 sides. So side angle, that's the only case where we potentially have to deal with 1 solution, 2 solutions, or no solutions. This never happens in any other case. All right, so that's one way to tell that it's law of sines. Does anybody remember the other way that you can tell by looking at the table? Something happens in the table if it's law of sines. Yep.
Isn't it like the whole row is completed?
Yep. You have a full row that's complete. Okay. We do have a full row, which means it's law of sines. We also have an empty row. When you have a row that's completely empty, that's useless. You can't do anything with that row. So we're pretty much forced to find something first here. What do we have to find first? Yeah?
Angle of beta.
Yeah, we have to find beta. And just because I know how this is going to work out, I would make sure you keep this box big enough as we go through the problem. All right, so let's set it up to find beta. So we're going to end up using that part of the law of sines. So we're going to fill in everything that we know. We should have 3 out of 4 of those spots be numbers.
Can you look at the capital letters?
Yeah, sure.
Also, I have the spots if you look at.
All right, so let's set this up. So first I'm going to write down what I'm going to do. So I'm going to find beta. Set up your proportion. And we'll fill in the spots. Give me 1 second. Okay. All right, let's fill this all in. I can always start with that. Now I need to know what's going to go in these 4 different spots. So what are we going to put on the left?
Sine 35 over 6.
Okay, so we got to put the information that we know somewhere. That's complete. So whether you put it on the left or the right, it doesn't really matter. But you've got to have sine 35 over 6 somewhere. And then wherever you put that, what goes on the other side? Yeah?
Sine beta over 8.
Sine beta over 8. Now, usually we cross multiply to get sine beta by itself, but that's actually just going to make more work for you. You don't need to cross multiply. All you have to do is one thing to put that 8 on the other side. So how can we move that 8 over to the left side? Yeah. You can, but that's going to make more work for yourself. Because the only thing we have to really move is the 8. If you cross multiply, then you're going to end up with 6 next to sine beta. Then you're going to have to get rid of the 6 after.
Well, yeah, but wouldn't that be the 8 next to the sign of 35?
And how would you get that over there?
You know how
You wouldn't cross multiply because that means you're going to do 2 things. You're going to multiply this first diagonal and the second diagonal. I just want to do one thing. Yep.
Multiply both sides by 8.
Just multiply both sides by 8. So just times 8 and times 8. Not sure if that's what you meant. But yeah, just don't do anything with this diagonal because multiplying by 8 puts everything on the side that you want automatic. Okay, so now we have 8 sine 35 over 6. And yes, if you wanted, you could reduce 8 over 6 to 4 over 3. But what's really the point? Because we're just going to type it in on the calculator. And whether you press an 8 and a 6 or a 4 and a 3, doesn't really make that much of a difference. Okay, so now we have sine beta by itself. But remember, we are solving for beta, not sine beta. So I need to do something that can get rid of sine.
Take the arc sine.
Yeah, take the arc sine or the inverse sine. And once we take the inverse sine of each side, it's going to cancel. I thought I wrote this. Guess not. Okay, so take the inverse sine of each side. Beta's by itself. And while we still have a functioning calculator, let's quickly type that in and see what we get. Maybe. First of all, make sure that you are in degrees because nothing in this section or 8.2 is in radians. 8.3, yeah, there was radians. Okay, so inverse sine of 8 sine 35. It's important you put a parenthesis after the 35 because it's like saying that we're done with the top of the fraction. Divide by 6. Close the parenthesis to let it know we're done with the bottom of the fraction. Now, one of 2 things is going to happen here. Either when we hit enter, it's going to say error, which means this could be a no solution problem, or we're going to get an answer. Okay, we got an answer. So this is not a no solution problem. That's one of the solutions right there. Maybe it's the only solution, but we have to check if there's a second one. So 49.886. Now, to see if there's a second solution, you have to subtract that number from something. Does anybody remember what you subtract that from? Yeah?
Well, you would add that and the other angle to get 180.
That's how we're going to get gamma, but we still have to see if there's a second answer for beta first. But yes, we are going to do that in a minute. But I need to check if there is another answer to this problem. Yeah?
Did you subtract it by 360?
No, we don't subtract it from 360. Anyone have another guess? Oh, yeah. You subtract it from 180. So 180 minus that answer. If there's a second answer to the problem, that's it. I'm not going to put it in the box yet because we have to see if that answer fits in the triangle. And by fits, I mean it can't be too big. So 130.116. So when I say it fits, let's think about what angle were we given to start this problem? Yep.
35.
We were given a 35. And I'm saying I think the second answer is 130.116. Can you fit 130 and 35 in the same triangle? Big Max?
Yeah.
Yeah, because it has to stay under what?
180.
Has to stay under 180. When we did this, right before we did the test, this second answer came out big enough that when you added it to what you already had, it was over 180. So it didn't it didn't fit. But this time it's under 180. Okay, so that means something's going to happen now. That means we are going to have 2 answers for beta. And once you know that there were 2 answers for something, there are 2 answers for everything. Well, let me say it this way. 2 answers for everything that has a box around it. The information that was given to you, that's done. We don't have to worry about that information at all. So the way this works is either everything in the boxes has 2 answers, everything in the boxes has 1 answer, or everything in the boxes has no answer. But those are the only 3 things that can happen. They're all 2, they're all 1, or they're all none. Question?
What is it like contingent upon to have no solution? Like I know it would come up as an error, but what causes that?
What happens is you're just giving information where the sides can't connect in real life to make a triangle.
Okay.
And I can show you that. I'll draw a picture of it, and no matter what you do, you just can't connect this side to this side. It just doesn't reach. That's what happens. And I'll draw a picture of this as well. Okay, so we got 49.886. So we know that was an answer. Then we subtracted it from 180 to get that number. When you add that number to 35, if it's under 180, then the second answer works. If it comes out over 180, like it did on the test, then it does not work. Okay. Any question how we got the 130 or how we figured out that it works? So what we're doing now is we are solving 2 problems at the same time. 2 totally different problems. We're using the same table to do it because the 2 problems share some information. So it's easier to use the same table. Let me kind of color code it so you can see what the 2 problems are. So we'll call it like the black problem and the red problem. In the black problem, well, okay, I guess I'm going to do red. In the red problem, we have an alpha, we have a beta 1, and we have a gamma 1. Those are the 3 angles in the red problem. These are the 3 sides in the red problem. A, B, and C1. In the black problem, the 3 angles are alpha, beta 2, and gamma 2. And if you're like, wait a minute, alpha's in both? Alpha's in both. Alpha is a piece of information that is shared between the 2 problems. And the 3 sides in the black problem are A, B, and C2. Yes, A and B are used twice. A is in both problems, and B is in both problems. So if you look up there, you should have 6 marks that are red and 6 marks that are black. 3 red sides, 3 red angles. 3 black sides, 3 black angles. All right. Now, let's get back to what Manning had kind of started to talk about, and let's find gamma 1 and gamma 2. Let's start with gamma 1. What 2 angles would I add up and then subtract from 180 to get gamma 1? Yeah?
Alpha and beta 1.
Right, we're looking at the red problem. So you're going to add up alpha and beta 1. So 35 plus 49.886 and subtract that from 180. Okay, so gamma 1 is 95.114. Now, you do have enough information at this step. You could just go ahead and figure out C1. But what I like to do is let's finish the angles first. Then we'll jump over to do the sides. Rather than doing an angle, then doing a side, then another angle, then another side. Okay, let's finish one thing off. Okay, gamma 2. What angles am I going to add up and then subtract from 180 to get gamma 2? Yep.
35 and 130.116.
Right, we're looking at the angles in the black problem. So 35 and 130 is 165. So take 180 minus 165.116. And that gives me an angle of 14.884. Okay, we're going to 3 decimal places because a lot of times I'm going to be looking for accuracy at least to the 2nd decimal place. So if you go to the 3rd one, then you should be okay for the 2nd one. If you round everything to the 2nd one, then that's going to probably mess up your final answer. So just go at least to 3. You don't have to do more. 3 is enough. Okay, so now we've got all the angles. Now we can find C1 and C2. One of the sides is in the red problem. The other side is in the black problem. Let's start with C1. To find C1, that's a red problem side. You need to use a row that has everything in it, and it has to be a red row. So there's actually 2 rows in that table that are red rows that have everything in it. Which row should I use? Yeah?
The row with A and 35 degrees.
Yeah, you want to stick with that red row, even though B beta 1 is a red row that has everything in it. We don't want to use it because the 49.886 was calculated by us and it's rounded. So we don't want that. So we're going to stick with sine 35 over 6. Let's set it up. So just write all this down. So sine 35 over 6. And what's the angle that I'm going to use to find C1? Yeah?
95.114.
Hey, gamma 1. You always use the angle across from it. So 95.114 over C1. Okay, so now we want to cross multiply to get C1 by itself. So remember the pattern that ends up happening. If you want to do the step in the middle, you can, but I'm gonna jump right to the final answer. It always ends up being the product of the 2 numbers that are on the diagonal with each other divided by the number that's on the diagonal with the letter. That's the pattern that always happens. So it's going to be 6 sine 95. And then you divide by the number that's on the diagonal with what you're solving for. If you cross multiply it, I mean, that's basically what I did. I just did the cross multiplying. But when I write it out, I'd have C times the sine of 35. Well, I don't want the sine of 35 next to C, so I have to divide by it to move it to the other side. And that's your answer for C1. So now, we just type that in and round it off. I know we're using a number that we've already rounded, but there's no way around it. You have to. Okay, so 6 sine 95.114 divided by sine 35. So 10.419. And the last thing we want to do is find C2. It's going to be pretty much the same calculation. But instead of using the 95, you're going to use the 14. But you're going to type in the exact same thing. So find C2. Since it's going to be pretty much the same thing, I can just use the final answer I had last time and change the one thing that's going to be different in the formula. We're still going to use the 6. We're still going to use the sine 35. The only thing we want to do is replace 95 with 14.886, or 0.884. And if you want to go through and set the whole thing up from scratch again, you can. But you basically already have the answer, just substituting one number for a different number. So why not just use what you already did. 14.884. And I'm going to use that same approach on the calculator. I'm just going to bring up the last thing that I typed in and just change the one thing that's different. 14.884. Everything else is the same. Okay. Also, if you notice, I didn't close the parenthesis on the sign 35. Not the best idea, but it's actually not going to mess anything up. It's because I don't have anything else being typed after the number 5. So, technically, it doesn't matter. 2.687. So that's a good problem if you're practicing for the test to try it again on your own and see if you get these same decimals, because I'm pretty confident we did that right. And if you're getting numbers like 2.987 or something like that, you're probably on the right track, but something's off with your rounding. So you want to make sure whatever mistake you might be making, if you are making one rounding, we fix that before the test. And that would be 6 points. Well, 6 problems on the test, because you had to find 6 things. If it was a short answer, that's what it would be worth. Any question on that? So now let me draw that. This I am going to draw to scale. I'm going to draw 2 triangles that each share a side, and an angle. But they're going to be different. So let's start with this. You can really just watch me do this because I'm going to end up with 2 pictures. But if you want to try to draw it, you can. Alright, so the first thing for side-side angle is I need 2 triangles that have two sides the same length. Let's start with this side. If I make a copy of it, do people agree that that side and that side are the same length? Okay. So I have a side that's the same. Now I need another side. All right, I'm going to take this side. I'm going to copy it. But then I'm going to find a mirror image of it. Now, does finding a reflection of something change how long it is?
No.
No. So it's still the same as the side that we had at the top. So that and that are the same. So now I have 2 sides that are the same. And all I can really do at this point is just draw the third side. Where's the angle that's the same? If you look, you should be able to see it. Anybody see where it is? Yeah?
Bottom left.
Yeah, it's the bottom left. And if I drag it up here, you'll see that the bottom left angles are exactly the same. That's actually a good picture if I leave it like that for a second. That's how you get the second triangle. You take the side that's, I don't know how to explain it. You take one of the sides and you basically mirror image it so it flips it in instead of being folded out. So now we have this angle, the same as this angle. So I've just drawn 2 different triangles that have 2 sides exactly the same length and an angle exactly the same, but they are different triangles. This would be like your beta 1, your beta 2, your gamma 1, your gamma 2, and then your C1 and your C2. So you have different answers. And that's the only case you can do that with. If you gave me like 2 angles and a side, I cannot draw 2 different triangles with that information. So if you had a protractor and like a ruler and I said to you, I want you all to draw a triangle with an angle of 20, 50, and I want the side across from the 20 to be 3 inches long. If people did it correctly, every single person's drawing would look the same. There is no way to draw two different versions without information. Can't do it. But this information you can. All right, let's look at this one. All right, we don't even really need the sketch. We should be able to tell that this is law of sines. Can someone remind me again what tells you that it's law of sines? Just looking at the table. Yep.
Is it because there's a complete row?
Yep. There's a complete row. So we know right off the bat we're going to use law of sines. And I have a row that's completely empty. So what does that force me to have to figure out first? You don't have any choices of what you're going to try to find first here. Yeah? You have to do it. Because B and beta is totally empty, so you got to ignore it for now. Okay, let's find out. So set up your proportion. Right, and let's start with what I'm going to put on the left. Casey, what can I put on the left side?
Gamma. Put the 50 in.
Okay, so sine of 50.
Yep. And over 1.
Yep, over 1. So there's the left side. And how about my right side? Quinn, what could I do on the right?
On the right, you're gonna have sine alpha and then 2.
Over 2. And again, you don't need to cross multiply here to get sine alpha by itself. Especially because this denominator is just a 1. So why multiply something by 1? It's not even going to change it. So Caleb, how would I get sine alpha by itself? Remember, I just said we're not going to cross multiply because we have a 1. Eventually we're going to do inverse sine, but first we have to get sine alpha by itself. So I want to know what would go here if you had that on the right.
This is probably what we did last week, right? Because I wasn't here in class, though.
We did, well, I mean, it's basically the same idea as if you had 3 over 2 equals x over 5. If you wanted to solve for x there, you just have to multiply both sides by what?
Sine would be...
Well, here you'd multiply by 5.
Yeah.
And the answer would be 15 over 2, or 7.5.
Yeah.
But what would you multiply by up here?
1.
2. Right? You want to multiply both sides by the denominator you're trying to get rid of, because your goal is to get eventually alpha by itself. But let's start with getting sine alpha by itself. So just times 2 and times 2. So now we've got 2 sine 50 on the left. Now we can get rid of the sine on the right. And what's going to get rid of sine? Yep. Yep. So take the arc sine or inverse sine, same thing. Do it on the left. Do it on the right. Now, if you remember, when you do inverse sine, the number that you put in between those two parentheses is supposed to be between two values. It's a very small interval. Does anybody remember what you're supposed to plug in a number between to do inverse sine? Yeah?
Isn't it -1 and 1?
It's supposed to be between -1 and 1. Well, before you type the whole thing in, check 2 sine 50. That's 1.5. So now let's try taking the inverse sine of 2 sine 50. Inverse sine, 2 sine 50. You're plugging a number into inverse sine that is not between what it should be. It's bigger than the biggest value that's allowed, which is 1. So what happens is we get an error. So what that means is you may want to double check you typed everything in correctly, but as long as you typed it in right and you set this up right, that means that there is no solution for alpha. Now, if we had alpha, what would we normally do at this point to get beta? If we knew what alpha was. Yeah?
You would add alpha and gamma and then subtract that from 180.
Right, you would add alpha and gamma and subtract from 180. But because alpha has no solution, you can't add it to gamma and then subtract it from 180, which means you can't figure out beta. And if you can't find the angle, then you can't figure out the side across from it. So what happens is once we know that alpha is no solution, the whole problem is no solution. So what that means is that's impossible to draw. If you tried to draw a triangle that had a side length of 1, 2, and an angle of 50, you couldn't do it. Okay, I'll show you what. But that's a no solution. So in terms of side-side angle, that's the best thing that can happen because you start the problem and you're pretty much done right away. Okay, let me draw it. So here's a triangle. That is exactly a 50-degree angle. I use the protractor thing on the board to measure it, so it is exactly 50. Now, I need sides that have a length of 1 and 2. It doesn't matter like 1 watt and 2 watt. The idea is one side is double the length of the other. So let's call that my side that's length 1. And then put 2 of them together. And that'll be my side that's length 2. Okay, so that's length 2. Let me just group them together. All right, now I started to draw the triangle. So A would be this side, B would be this side, C would be this third side on the right. First thing is side A. That's the long one. That's 2. So I need to make sure that I put side A at exactly a 50-degree angle because I need to get that angle. So I'm going to set this at a 50. Why can't I just get it back the way it was? Usually undo fixes everything. Okay, well, let's just create it again. Okay, so ignore those. So there's my side length of 1. Make a copy. Make a copy. There's my length of 2. Close enough. Okay, so now I need the long side to be tilted at 50 degrees. Let's see if I can just try to get. Oh, I did it again. It's breaking it apart. Close enough. We'll just go with that. That looks good. So that's now at a 50-degree angle. I can't mess with the tilt of that line now. I need to keep it tilted the way it is. Now the short side is side C. That's the side that comes off the top of A. So C is over here. Now, it doesn't say what this angle is up here. So this angle can be anything you want because that was one of the ones that was a box and was not given. So in order to be able to rotate, I can't rotate that because it doesn't have the green handle on it. But the only way I can rotate it is if I group it with something. And then I can erase the dot. And now it has the green handle. So now I can rotate it. Right, so you can put that however you want. What you can't do, though, is change the length of this side. It has to be half as long as the other side. And that's how I drew it, so I know that's what it is. Now, the third side, side B, I don't have a length for. That was something we had to solve. So the third side can be as long or as short as you want. What you can't do, though, is tilt it. It has to stay horizontal. Otherwise, you're going to mess up that 50. So the length of this side has to stay the same. The length of that side has to stay the same. And this angle has to stay 50. The two things you are allowed to change are this angle. You can make it whatever you want. And this bottom side, you can make as long or short as you want. That's all you can change. So if I change it, am I ever going to be able to get these to connect and make a triangle? No. Okay? Even if I take this and try to, well, even if I could shorten it, oh, there we go. Even if, so if I shorten it and then say, all right, well, I'll tilt this a little more like that. I don't care what you do, you're never going to be able to make that connect. The only way you could make it connect is either allow this angle to be smaller, and then I could tilt this side up. Or tell me that this side doesn't have to be 1 unit long. Let me make it longer. Okay. Or maybe I could make this side shorter. Okay. But with the information they gave me, it's impossible to sketch. Any question on that? Right, so that's what the no solution looks like. It's just not possible to draw a triangle that actually has all the sides meet. Okay, and let's see this one. So we're going to look at a problem where we're basically going to be measuring the height of an object in the distance. And the way we're going to figure it out is we're going to take two measurements of that object in the distance. The object we're going to try to measure is a mountain. And the way you can find the height of an object, any object, in the distance, you don't have to know how far away you are from it. You don't have to know how tall it is, because that's what you're trying to figure out. All you have to know is what's the angle from where you're standing to the top of the object you're looking at. But you have to know it from two different spots. So what's going to happen is a surveyor is going to set up their equipment in the first spot, point like a laser at the top of the mountain, and get an angle from where they are to the top of the mountain using a laser. Then the surveyor is going to back up and do it again. It doesn't matter how much they back up. They just have to know how much they back up. They could back up 600 feet, 6,000 feet. They just have to back up in a straight line and continue away. So the first time that the surveyor measures the angle from where I stand right under the lights and I want to know what my angle is to them, well, if I'm almost right under them, it's very steep. Right under it, it's like 90, straight up. But if I start to move away from the lights, now the angle to the light isn't 90 anymore. It's not straight up. It's maybe more like up, and there's like another one set up further down. They could be measuring like the distance between properties. They could be measuring the road to see if there's like a slant to it so the water runs off. They're measuring something. Now, technically, a transit is not on the ground. It has a height, might be like 6 feet off the ground, so the person can look into it. Well, we'd have to take into account the height of the tripod normally, but we're going to pretend that the transit is right on the ground. So maybe the person is like laying on their stomach and looking through something, but it's on it. It just makes it all simpler. Okay, so there's a ton of information there. What do you think we should do with all that information to make it easier to think about this problem? Yeah, yeah, we definitely want to draw it. Now, I don't want you to think about drawing triangles. I just want you to think about putting the objects in this word problem in a diagram. And if you put the objects in and draw what you need to, triangles are just going to happen automatically. So what's one thing that we definitely need in this picture? Yeah? So let's talk about labels after. For now, let's talk about words, just objects. But we are going to put labels in too. Yep.
The peak.
Okay, the peak, which is part of the mountain. So we need a mountain. What else do we need? Before you can even put a mountain in the picture, you need to put what in the picture?
The ground.
We need the ground, right? We can't have a floating mountain. So we got to put the ground in the picture, and then let's draw a mountain on the ground. So here's the ground. Here's the mountain. I don't know, something like that. And two other things we need to put in this picture. We've got the ground, we've got the mountain. What else is in all that needs to be represented? Yeah? The surveyor. The surveyor is going to measure the peak of the mountain from two different spots. So let's say there's the surveyor the first time, and there's the surveyor the second time. Each time the surveyor measures it, they take their laser and they point it at the top of the mountain. I'm going to represent the laser with a dotted line. And then he does it again. Points it to the same spot. Now, what do we know about the first spot and the second spot that the surveyor measures from? Something we know about those two spots. Yeah? They are 900 meters apart. Okay, so now we've got all the objects that we need in the problem. We got the mountain, we got the ground, we got the laser pointing at the peak. Now we need to put in some labels. So we've got 900 meters. And so I don't have to scroll back up because it'll probably freeze. Can somebody tell me what was the angle of elevation the first time the surveyor measured it? It was like 40 something?
47.
So 47. And what was the angle of elevation the second time? We know it went down a little because he backed away from it. Yep.
It's 35.
35. So let me draw what we're trying to find. What we want to know is that. That's the height of the mountain. If you could draw a line straight down. So let me take that triangle and pull it out of the picture, and let's look at it by itself. Okay, that's a 90. So here's our triangle. And what kind of triangle is that? Yeah?
Right triangle.
That's a right triangle. So all we really want to do is solve that triangle for h. If you can find h, you're done. But there's other information over here we haven't even put in this picture, so probably you're going to have to do something else first. Well, we know this is 47. Can you solve a triangle if all you know is two angles? Or technically, you know all three angles? No. It's like if I said to you, I have an equilateral triangle. Every angle is 60, 60, and 60. Tell me how big the sides are. You don't know. It could be 2, 2, and 2, or 50, 50, and 50. The problem is, to solve a triangle, you need to know at least one side. If you don't have one side, you don't have any scale. So, unfortunately, this red triangle, we can't use it right away, but we can come back to it. So we'll come back to that diagram as soon as we figure out one of these other sides somehow first. Well, there's another triangle in this picture, and we have a lot of information in that triangle. That's this one right here. Not drawing the straightest, but let's take this triangle. And before we even label anything in it, there's something that the black triangle and the red triangle have in common. Can anyone tell me what they both have in common? Yeah?
The length of that top line.
The length of the what?
Top line, the C value, the hypothesis.
Yeah. If you line them up, they share a side. So if we have enough information to figure out the side that I just checked off, then we can put that side in as the hypotenuse in the right triangle, and then we can solve it. So let's label everything we know about the black triangle and then go from there. How long is that bottom side? Yep. We know that's 900. How about the bottom left angle? Yep. We know that's 35 degrees. Now, we don't have the bottom right angle, but we have enough information to figure it out. How would you figure out that angle right there? Yeah.
You would subtract 47 from 180.
Yeah. Take and subtract 47 from 180, and that gives me 133. Now remember, the key for law of sines is you have a full row. What does that mean as a picture? It means you know an angle, and you know the side across from it. I still don't see in the black picture an angle and the side across from it that I know. I don't know what's across from the 35. I don't know what's across from the 133. But what else can I figure out in this picture? Yeah, I can get the third angle, and then I'll have an angle and a side across from it. There's my full row. Then you can figure out anything you want to know in the black triangle. But what we really want to know is, we'll call that side C. Okay. And Max, how would you get that third angle?
180 minus 35 plus 43.
Yeah, so if we add those up, 33 and 35, that's going to give me what? 168. So these add up to 168, which means this angle right here is 12. Okay. Now, just to be clear, C is not the height of the mountain. That's not the height of the mountain. The height of the mountain is H. But I can't get H until I know something else in this red triangle, and that's what the black triangle is helping me figure out. Okay, so let's find C. Find C. So as far as the diagram, we're done. We've set up the diagram. That's the hard part, just kind of visualizing it. Now we just got to crank through the numbers and figure out what these sides are. Okay, what could I put on the left side of that proportion that would represent my full row in the table? Yeah.
Sine 12 over 900.
Sine 12 over 900. That's your full row. Sine of an angle. Divide by what's across from it. And now I want to know C, because C in the black triangle is the same as C in the red triangle. It's the hypotenuse. What angle am I going to use to get C?
35.
35, because it's across from C. Okay, so cross multiply, and let's see what we get. So multiply the two numbers on the same diagonal. So 900 sine 35, and then divide by the number that's on the diagonal with the letter. Let's figure out what C is. So it's 900 sine 35 divided by sine 12. So C is 2,482.88. 2482.88. 2482.88. Which means that is 2482.88. Because those two sides are the same. Now I can figure out C. And I don't need to use law of sines or cosines. This is a right triangle. So I just have to figure out sine, cosine, or tangent. Here's my angle. What position is side H relative to 47? Yep, that's opposite. And what about side C?
In relation to side C,
Well, the angle, 47.
it would be adjacent. Oh, hypotenuse.
This would be adjacent down on the bottom. That's the hypotenuse. Because it's across from the 90. So now, we know the hypotenuse is 2,482. We're trying to solve for opposite. What trig function has opposite and hypotenuse in it? Is that sine, cosine, or tangent? Yeah, sine. So this is not law of sines anymore. This is solving a right triangle, which you could use law of sines, but that's more work. So sine 47 equals opposite over hypotenuse. Sam, what's my opposite here?
Not gonna lie, I'm not following along. I'm trying to write.
Well, which side in that picture is labeled as opposite?
H.
H. H is my opposite. And we need hypotenuse, but we know that it's a number. Yep.
2,482.88.
And the last step to get H, which is the height of the mountain, we need to get H by itself. Aiden, how would I get H by itself there?
You multiply by 2,482.
Yep. Multiply each side by the 2482.88. So 2482.88 sine 47. So based on the measurements that the surveyor made, the height of this mountain, and I think that was meters, is 1,815.86. And that's right there. That's the work pretty much to do the entire problem. But I don't know how easily I could do it without a diagram because it would be hard to visualize what is across from what and the fact that these two sides are shared. You need a diagram. Okay, so any questions on that? Yeah.
Just go like this level to show us to see.
I don't think. Oh yeah, I did have that. Sorry about that. So that finishes up law of science, and that covers the first three cases that I wrote down. The last two cases, which we're going to look at tomorrow, are side angle side and side side side. Those cases are going to be what we call law of cosines. So tomorrow, a little different formula, but the goal is still the same. Find the sides, find the angles. And then that'll finish up this kind of.
You say we're doing one that's side, side, side?
We are going to do side, 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 yeah. And if you think about side, 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 you couldn't do it with law of sines because remember, you got to have a full row. Well, if you know a side, and a side, you don't have a full row. So that would be a problem. Same with side angle side. That would also be a problem for this one. So that'll be part of what's on the test too. It's not going to say to you, use law of sines to solve it, or use law of cosines. You got to figure out which one to use, and then use it. Okay. Any question on that? All right. So that's the homework for tonight. It is possible some of those are no solution. So if you get a no solution, doesn't mean you did anything wrong. There are some no solutions.